Hey everybody, I'm Michael Monaco.
And I'm Bobby Salveson, and we are the Hazmat Guys, bringing you the knowledge and insight to make your job a little bit easier and safer. But before today's show, let's listen to our sponsors. Hey guys, did you know that CBRNE Convergence is heading back to Orlando from the 6th to the 8th of November 2018, bringing you 3 days of workshops, lectures, and interactive sessions delivered by speakers from around the world on the latest issues and approaches to CBRNE and Hazmat. This year's pre-conference workshop is on mass fatalities, a must for first responders. To register for the visits, go to cbrneworld.com/convergence2018. Hey guys, you've heard us talk about Dahlgren Decon and its effectiveness on fentanyl, chemical warfare agents, and ticks and TIMs. Firstline Technology has launched a new Decon field guide app for your iPhone and Android device. It has a complete threat library and explains Dahlgren Decon functionality against bulk contamination and contaminated surfaces. It also has complete instructions for mixing and applying Dahlgren Decon, as well as reactivity concerns, suggested ratios, and dwell times. Download today on the Apple App Store and coming soon to Android. Hey everybody, we have a great episode coming up today, but before we start the show, we want to share some exciting news from the Hazmat Guys. As some of you may know, we have been working on a hazmat drill book for quite some time, and we're pleased to announce that it is finally available on Amazon. This book was written by contributors from the hazmat community based all around the United States, and we think it will provide a ton of value for both you and your department. The title of the book is The National Emergency Response Hazmat Drills, 50 Drills to Improve Your Team, better known as NERD. No, this was not a mistake. Anyway, the goal of the book has been to help the hazmat community, and we hope that you'll take a moment to check it out and share it. We have the link in the show notes, and if you have a moment, please leave us a positive review in Amazon. We'd be very grateful. We wanted to get NERD on the bestseller list and give more exposure to our community. Again, the book is called National Emergency Response Hazmat Drills, 50 Drills to Improve Your Team, and there's both a paperback and Kindle version available. Thank you, everybody.
Now let's get into the show.
Hey everybody, welcome back to another episode of the Hazmat Guys. Today we are continuing our series on hydrofluoric acid and all the happiness that goes along with it. If this is your first time hearing us do the hydrofluoric acid, we have a couple of previous shows, one very educational show, and then the rest of them are going to be interviews which we talk with people who have firsthand experience actually dealing with the product. Today we have Stephen McManus, who's going to be with us. He's had a whole bunch of different instances, both in the public and private sector. So, Stephen, why don't you tell us a little something about you?
Yes, thank you. Good morning. Background, I've been a career firefighter, career fire service, also volunteer fire service, and did a stint in the industrial side, and now I'm actually back into the industrial side as a career chief for an industrial fire department. And yes, I've had some unique issues with hydrofluoric, both as a public responder and in the private industry. One of the things I was going to tell you about, a little story, this happened back in the 90s. It was something very unique where not only because of the hazard of hydrofluoric acid, but also other things that are combined. We did some very unique things. I worked on a high hazard team that went around the world doing different things for different governments. And in one particular case, which is probably one of the more dangerous operations we did, we were actually working at a facility that had been abandoned for about 10 or 15, maybe even 20 years. And in the process of working through the risk assessment of different areas in this facility, it was noted that there was chemicals stored. One of the chemicals happened to be a 55-gallon drum with hydrofluoric acid in it. There were other chemicals also stored in that room which were just as hazardous. For instance, uranium hexafluoride and pentafluoride and a number of other different chemicals. Well, the other unique twist to this, not only from the hydrofluoric standpoint, was that we were very concerned about a criticality issue in this room because it had been abandoned. So we were mandated to go in and try to resolve not only the hydrofluoric acid, but the potential dealing with enriched uranium in this room, which kind of adds a twist that most people don't, it's bad enough dealing with the hydrofluoric, but now you got the other twist of possibly enriched uranium. The interesting thing was it took months to plan for this incident because this room was only about a 5x5 or 5x8 size room. And the hydrofluoric acid drum that contained the product was so rusted and damaged that we were afraid going in there trying to work around it and work with it that we could possibly have a rupture of the drum, which, if you know anything about criticality issues, if there is a criticality issue, changing the molecular structure in the area can cause an issue, a big issue, not only from movement but also from a chemical release. The interesting part is we had a number of agencies watching over us doing this, so we had to plan this all out and put a special team together to just go inside and deal with it. In the process,
real quick, what is catch me up to speed on what you mean by a criticality issue? Are you saying that you guys walked in and there was like kind of like a holy crap factor, or what do you mean by a criticality issue?
This particular facility had been involved with weapons, and the basically enriched uranium contamination, and if you do certain things, you could actually, the old proverbial flash in the sky, that's what we were dealing against. Obviously in a much smaller factor, but we had to be able to do all the health physicists that were working with us had to do all the calculations because the area was so contaminated, they couldn't pinpoint the readings from any one area. So they thought there were things in this room that if we went in and moved things around the wrong way and caused an issue with the enriched uranium, we could actually have a big bang.
Wow.
So like I said, even though this is a hydrofluoric program, that was a big concern also, because now we have a 55-gallon drum sitting in this room that pretty much, and with the funny at the end, I'll tell you that you could take a pencil and actually run it through the drum. That's how rusted the drum was. But the bladder was basically holding everything inside the drum. And one of the tasks that we had, besides dealing with the criticality and the other chemicals, was to offload this hydrofluoric acid and safe that particular task so that we can continue on removing the other chemicals and then ultimately working on the potential criticality issue. So it was a kind of a multi-point process to deal with this particular incident. So it took a lot of different people from various backgrounds to sit down and design safety programs, safety plans, and then ultimately go in after all this was worked out and approved to actually go in and do the work. And the other unique thing was, because of the size of the room, in a little 5-by-8 room that had been abandoned for years, no one else knew what possibly could be in there or hidden in there. As it turns out, there was a lot of other things we found in small quantities. But the interesting part was going in with, if you know hydrofluoric acid, which most of your viewers do, that you know how bad it can be and what it can do. The interesting thing is everything that we planned for and practiced with and did everything, kind of Murphy's Law kicked in the middle of doing stuff. We were working in level A suits, and we were actually using peristaltic pumps to transfer product to a new drum. And lo and behold, the worst thing that could happen was you wind up getting a leak with the tubing from the peristaltic pump, which it happened to do.
What is a peristaltic pump?
Basically, it's a pump that allows you to create a suction, but actually not run the product through the pump itself. It uses tubing that goes around. You ever see in a hospital where they do blood transfers?
Sure.
That same process, where the tubing is compressed and it basically creates a suction up motion, which allows you to transfer the product out of the one tank, putting it somewhere else, and then in turn, but the product never comes in contact with the pump itself. It's all contained inside the tubing.
And I assume that that's kind of the reason you went with that style pump was because then you don't have any kind of internal pump contamination of the hydrofluoric acid, so you don't have to worry about things not getting along inside the pump, things the pump had previously been used for, things along those lines?
Yeah, because basically once you're done with the hosing is disposed of as contamination, and the pump itself has no contact with the product itself. And the hydrofluoric acid would have just destroyed the pump if it had been pumping through it. So it's basically the pump's kept clean. The tubing itself is everything that's contained inside the tubing after the fact is then discarded as a waste. So there's no cross-contamination between the pump and the tubing.
So did you guys pump from the room out of the room, or did you pump from one drum to another right next to each other and then pull it out? What was the ultimate decision on that, and why?
We had to wind up pumping one drum to another in the room because of the other issues in the room, as I mentioned, because of the criticality issues. So we had to do a lot of finagling and moving things very cautiously to be able to bring a newer drum in, a brand new drum in, to put it close enough to be able to transfer product from the bad drum into the new drum. So then be able to take that drum out after making sure it was clean and there was no issues from RAD, and then removing that drum from the room ultimately. But as I was saying before, Murphy's Law kicks in, and in the process of making the transfer, we wound up having a pinhole form on the tubing, which ultimately allowed hydrofluoric acid to start escaping in the room. And because of the size of the room and the temperature and the humidity outside, that it wound up becoming a very unique response from that standpoint, where now we had to change and go to our plan B or plan C. And one of the funny things that happened, not now at the time, but afterwards, was one of the agencies that was watching us, we had to install TV systems, cameras in the room, because they were watching, because there was a lot of issues. And everyone's aware, hydrofluoric acid and glass don't combine that well together, and it wind up starting eating the lens of the cameras out. And in turn, they were concerned that they couldn't see us operate anymore. Not from a safety standpoint, they were more concerned from a jurisdictional standpoint. So we had to deal with those agencies and getting them off our backs so we continued working in a safe mode, because it was basically they wanted us to stop in the middle of the leak and fix everything for them. And we kind of told them, no, there's no way that's going to happen. Just leave us alone and let us do what we have to do.
Wow. So you ended up getting a small pinhole leak, and you had enough vapors form from that small pinhole leak that you had reactions with glass. What was, when you did the safety briefings and the other chemicals, what was that process like when you realized that you had the leak? Like, you guys stopped? Did you try to patch it right away? Did you just walk away and say, all right, we can't continue down here until other people have confirmed that there's not going to be this massive issue because of the vapors? Or is it one of those things you knew ahead of time, like, all right, if we have a leak, this is what we have to do because we're going to have X, Y, and Z happen?
No, we had pre-planned everything, and we actually had a plan. The first plan, A, B, C. We went as far as B. I'm sorry, as far as D, C, all the way down. So if one thing happened, we'd move to another. In this particular case, what we call the E's, but we were able to remove, because the tubing again is not part going through the pump system. We were able to withdraw the tubing from the pump system, drain it back into the original drum, take that tubing, remove it, and then add a new section of tubing in. So we were prepared potentially for any type of leak. So we had a number of backup systems already in place and backup pumps. If the first pump failed, we go to the second pump. If that failed, we go to a third pump. And we had the tubing and everything cut to length, so that was an easy transfer over. But again, working in a level A suit in a very hot environment, a very confining environment, and trying to get all this stuff working. And if you've ever had the opportunity to work with a peristaltic pump, trying to get the tubing in place while you're operating in a level A suit becomes a very big issue. And the process took a long time, so we had to stop, doing things, shut the system down, take breaks, pull guys out, go through our deconning process. I think in like 3 days or 4 days of working there, we went through 10 or 12 different level A suits, just destroying them, getting rid of them, sending them back out, not using them again.
Just for the hydrofluoric acid transfer?
And everything else. And also the potential for contamination. The good news was, at the end of the operation, we were able to transfer all the product, even though the agencies weren't happy that we tore up their cameras. But we did it. We were able to transfer all the product from one drum to another drum and deal with the other chemicals in the room, plus knowing and finding out later on, doing more extensive research and scanning and the surveying in the room, that we wound up not having to deal with a criticality issue after the fact. So the real hazard wound up being mostly the hydrofluoric acid, the drum, and also the other chemicals. And we were fortunate enough that when it did leak, that we reacted fast enough, shut stuff down, made transfers, cleaned up, and be able to continue the process without impacting the other chemicals or the potential impacting a criticality issue.
That is pretty amazing. I'm still trying to wrap my head around this multiple hazard with the uranium and this and that. And I know it doesn't fit into the aspect of the hydrofluoric acid, but what was it like to work within? Were you guys working within the time restraint of the radiation or the level A? Which was the limiting factor to the work environment?
In this case, it was the level A.
It was the level A.
Yes, we were not working in high dose areas. That was the good thing.
Okay.
We were working. Our limitation was working in level A in extremely hot environment, very humid environment because of the humidity with the HF is really bad. So those are our big limiting issues. Plus, just trying to maneuver inside of a room without knocking anything over. Because initially the drum was the first thing that we had to deal with, so that allowed us the room to be able to move around this small room and then deal with the other chemicals as we could. Because you just couldn't walk into a room and pick up a bottle or pick up a glass or a vial because of the potential for a criticality issue. So it would be nice. If we didn't have that problem, it would have been a heck of a lot easier just moving around and shifting things and moving things out and then dealing with the drum. But it was kind of the other way around. You deal with that hazard first, knowing the hazard of the hydrofluoric, knowing the condition of the drum. And as I mentioned earlier, after the fact, after we got everything removed from the drum was so badly deteriorated from sitting for so long that literally you could take a pencil and drive it right through the outside of the drum.
That is absolutely amazing.
It was basically the rust holding the drum together.
That is probably one of the coolest things I've ever listened to. To have that many hazards in that such a condition, along with the radiation and all that other stuff happening, that must have been really an amazing thing to have been on. Was the hydrofluoric acid the worst chemical in that room?
Well, you have uranium hexafluoride, which is also a very bad water-reactive chemical. But in this case, because of the volume of the hydrofluoric in there, and kind of it was like the elephant in the room that had to be dealt with. So I would say, from a chemical standpoint, that was the highest hazard. From a rad standpoint, it would have been the enriched uranium, which turned out later after doing more surveys and able to do a more thorough job. That wasn't in the room. So ultimately, the hydrofluoric became the number one hazard in the room after the.
And you said you went in with the level A. What were the conditions that led you to choose that level of protection?
Because we knew some of the chemicals that may have been in the room, because we did know that the drum was potentially the hydrofluoric, even though we still, it was labeled, we knew it was labeled, and they had a historical history that that's probably what was in the drum. But again, we weren't sure, so we chose based on our workups and the safety documents and getting ready for this, that level A would be the ultimate protection for the guys going in. Okay.
So it was, even with the, because we so often say in the first responder world, listen, like, there are pluses and minuses to that level A. If the benefits of being protected by that chemical outweigh the dangers of working in it, then it may not be, it's that risk benefit analysis. So that's what I was interested in hearing was, absolutely, even with that risk, it was worth it to be in the level A.
Oh, yeah, there would have been no other choice. No other choice. In this particular case, not to say you're not right, it's based on your risk assessment and your evaluation of what you're coming up against. Is the risk of a level A benefited by using it or not using it and going to a lesser protection? Yeah. In this case, though, like I said, we planned for this particular incident for months, and we looked at all the variables. What's the best level of protection? What if this happens? What if this happens? What do we do? And the ultimate decision was level A would be the best protection and give us the most time to work inside, the room, and then get back out and do what we got to do. So that was the ultimate decision.
Do you remember the decon that you did for that job?
Yeah, we did. We actually, even though we did a level, we did wet decon. We used some chemical mixtures, and I can't think of what we mixed. Like it's been a while ago, but we did do a wet decon on it, and that was based on the potential of not having any contamination coming in contact with any of the hydrofluoric or other products. They basically, the suits were kept dry except for the one time we had the leak and the vapor forming in the room. But we basically did a wet decon because of other issues in the room. And then we had to contain that decon water, and that had to be tested. We had to go through a whole process in case we took any contamination outside, and we had to do scans and everything else.
So with all the advances that we see in the decon world today, and the choices that we have, would you still go with the wet decon? Do you think you would consider wiping it down? Do you think you would consider some of the oxidizer sprays that are out there for decon? or do you still think the wet was probably the best way to go?
I think maybe we would have, especially, you're right, with all the new decon processes out, or solutions, or the oxidizing sprays and things like that, we may have looked very favorably on changing from a wet to what we have out today. But back then we didn't have a lot of the different options. You either had dry or wet, or you used an adhesive to pull off. But because of it not having all these different choices we have today, we chose the wet. Would I have changed? Probably. We would have looked. The other thing too is, at the time we would have to look at today's standards. Is, would that material have any reaction from the rad standpoint? Now we know it doesn't, but we might have used some of those options instead of a wet decon. And also, when I say wet, we were very limited. It wasn't like we were walking through showers. This was more of a handheld pump system and slow wipe downs. So there wasn't a lot of liquid used in the process for the decon. And the suits were known to going to be thrown away. That's why we went through so many level A suits. We were just worried about getting the person out versus saving the suit. So the suits were, once they were cleaned off enough to get the person out, the suits were then discarded immediately, and then a new suit would be used to go back in.
Very cool. All right, what other crazy, interesting hydrofluoric acid runs?
Crazy. We had another task we were tasked with one time is, again, dealing with a weapons program, dealing with cylinders. And if anyone's ever had the option of having to deal with cylinders that have been buried for many years, the unique thing is there were chemicals mixed with chemicals, and there were so many different ones that were mixed. But we actually had to work on a couple hundred cylinders, lecture bottle cylinders, which are the lab-type cylinders, and these were specially designed with valving on both ends, but they were being stacked with multiple chemicals, multiple gases, I should say, sorry, not chemicals, multiple gases. And we came across one that had a mixture, and I can't remember what was mixed with the hydrofluoric, but you would never mix some of these things together in your right mind unless you were trying to do something with it. And we had to deal with drilling into the cylinder, removing the product, and running it through a scrubber. And this one turned out to be, through lab analysis and testing, one of them happened to be a hydrofluoric cylinder mixed with something else. And in the process, and I'm laughing now because back then it wasn't funny, but we were working and running stuff through the cylinder, running out of the cylinder, running through a scrubber system. And because of the stacking of the different gases with the hydrofluoric in the cylinder, it wound up reacting with the scrubbing unit. And you have to envision this, looks like a 55-gallon drum with a series of controls and valves and different medias that we ran stuff through. And all of a sudden, the scrubber reacts. And the scrubber, even though it's sitting on a pallet and probably weighs 400 or 500 pounds, this scrubber starts to dance off the floor and starts to spew black liquid from one of the charcoal filter systems, because of the hydrofluoric mixing with the other gases and going through within the scrubber. And then wound up, we had to do an emergency response internally to ourselves, because this isn't, now you have to envision, this is this scrubber is inside of a unit that's special scrubbers also for the unit itself, for the air, and it's got airlocks getting in and out of it. So we're trying to stop the reaction from going critical, and trying to deal with the cylinder now that's being offloaded into the scrubber and shutting that down, because we had to drill the cylinder and use a collar system to withdraw the product from it. So we had to wind up dealing with shutting the scrubbers down, trying to neutralize the gases that are already being pumped into the scrubber, deal with the cylinder itself. The only good news was that because of it being a lecture cylinder, much smaller cylinder, so a lot less product being dealt with. But that became a very interesting thing, having to neutralize everything and trying to shut the scrubber down, which had to be rebuilt after the fact because of what happened to it.
Wow, so you guys, I've never heard of a process like this, so I'm kind of intrigued in and of itself. You literally, what you put, almost like a hot tap in a rail car, like you just kind of, you put a collar on it and you drill a hole, and there's already a high pressure tube connected to that cylinder. How does that work? How do you drill a cylinder?
There is a group that we work with that we designed actually a lot of the remote openers and stuff that happen today when people open containers, reactive chemicals. This team put together a lot of those opening devices. And this is going back into the late 80s, early 90s. And one of the systems that was invented by this group, the High Hazard Group, was, and they had some of the best gas guys in the world working on this, and cylinder guys, is they designed a collar system that was able to be mounted on pretty much any size cylinder, and being able to drill into a cylinder would draw the drill bit and still allow the gas to be contained inside. You're basically creating a valve. The valving is bad for the cylinder itself, so the collar system wraps around, locks in place, seals up around where you're drilling. In turn, you drill it, you would draw the drill bit to enough point where then a valve system is swung in place that's already in a closed system, and then basically it's a chambered process where now you've entered a valve into the collar system, which is not to say entered, but it's already built into it, and now that becomes the valve that you allow to pull product from.
That is one of the coolest things I've ever heard of.
FLIR, a global leader in CBRE and detection, announces a new version of the Identifinder R200 spectroscopic personal radiation detector that now detects and identifies neutrons in addition to gamma radiation. Neutrons penetrate material and travel far greater distances than any other form of radiation. A neutron detector has a better opportunity of detecting neutrons before any other associated type of radiation. This capacity provides an early warning to malicious material and provides a vital situational awareness to the user. This ruggedized, pager-sized detector can be mounted in a vehicle or worn for 24/7 radiation monitoring. While being worn, the Identifinder R200GN operates like a personal radiation detector, alarming when radiological hazards are detected. Responders can also use this device to perform isotope identification to help make safe and informed decisions. The Identifinder R200GN enables responders to determine whether a detection is a true threat or something a little more benign in nature. The R200GN uses the same Identifinder interface that responders have come to know, making it a seamless addition to the response toolkit. Find out more about the FLIR Identifinder R200GN by visiting www.flir.com/R200.
So you have this cylinder, you've drilled it, it's attached to the scrubber. You did or didn't know at the time it was hydrofluoric acid. Is this one of those things?
No, we did know.
You did know.
We actually, the drilling, it was kind of unique in this particular case. We actually had a mobile lab built, pulled into the site, and we set everything up where we would take these cylinders after they were unearthed, and then in turn we would do an analysis, a risk assessment on the cylinder, the valving, try to determine from exterior information what it was. But a lot of these have been buried for 10, 15, 20, 30 years in some cases. And we then we do a collar work on it, pull a sample inside the lab, inside a vapor hood system, and then in turn that was done, an analysis was done on that by lab people inside the mobile laboratory. Then once it was known, it was properly identified and tagged. But in some cases, it was difficult because of the different gases that were stacked. And people are going to say, well, why would you stack those gases? And that's some of the questions we were asking also. And without going into big detail, there was a lot of things that people were experimenting with, stacking different things inside these cylinders. So in turn, trying to determine what each level or each stratosphere inside the cylinder was, and then making a determination what's the best way to neutralize these all together. Now, the good news is most of them, when they were stacked inside the cylinder, they weren't reacting with each other because otherwise the cylinder would have come apart.
Right.
But once we got at least the majority of what was stacked inside, then you get to do the pull off and then run it through a scrubber, knowing at least what the majority of the products are inside that cylinder.
So once the system itself started to react, how did you end up dealing with that? Because you still have a cylinder of hydrofluoric acid. It's still going somewhere, but I'm assuming you can shut it down?
Well, what we did was we since, like I said, now we have this valve system off the collar, we were able to shut that off and remove the cylinder from the system. In turn, unfortunately, because the reaction had already started, it was basically clear everything out of the way, have our levels of protection and stand by and try to disassemble the scrubber as much as possible. The actual physical reaction in the main scrubber, we couldn't do anything about it because you would have to have unbolted the different chambers and the different stacking processes. So it was kind of sit back, watch, and see what happens as this thing is rocking and rolling on the floor. Then ultimately, when it went through its final gyration, we were able to get in and pull the whole thing apart and then start looking at what kind of damage was caused inside the scrubber. Now, the good news is, as I mentioned, the scrubber was already inside another room that has another scrubbing system to it. So it wasn't like it was this product or gas was released into the environment. It was released into a room that was controlled, and the atmosphere was controlled inside that room.
And what level of protection did you end up going with that? Because I'm assuming if you have a reaction, there's the potential for fire hazard, but you also have such a high chemical exposure. What did you end up deciding to?
That was that. Luckily, that particular day, the guys working in that particular area were in level A.
Okay.
Because again, you're right. There's the fire aspect, but also we have to look at the toxicity of the known gases that we were dealing with, and that kind of outweighed the fire potential or an explosion potential. Now, also the scrubber was designed too to have, if it breached, that it would blow off as opposed to rip apart. So there were, for better lack of a term, almost like burst discs on it, where it would reach a certain pressure and blow out, and then that atmosphere would then be captured by the actual containment room.
Gotcha. So kind of a self-contained unit inside a self-contained unit inside a self-contained unit.
Kind of like that, yeah.
And that was, so the drum that you had was, because we talked a little bit in the last show about the differences between the aqueous and the gas, very similar to ammonia, where it can be, you can either find it in the gas form or you can find it in the cylinder form. And all of our gases will be in that cylinder form, and all of our aqueous solutions will generally be in a drum form. Am I correct in saying that?
Well, in this case, no. Because they actually pumped liquid into, not this particular cylinder, but in other cylinders where they mixed liquids and gases in the cylinder. And they by deliberate means, it wasn't by accident.
Okay.
Where they actually they pumped certain chemicals that were still in aqueous solution into the cylinder, and then they stacked gases on top of it. As to why they did that or what the experiment was, we don't know what that was intended to. We just know that when you with certain cylinders, when you actually, after the cylinder was inspected and reviewed after it was dug out of the ground, you can actually tilt the cylinder back and forth. One of the methods of listening what's inside of it, and you can hear the liquid rolling back and forth inside the cylinder.
Is there, so you unearth these cylinders. For hydrofluoric acid, can you walk me through the method by which you actually do a cylinder assessment? Is there anything different for the hydrofluoric acid cylinder as you would any other?
And no, in this case, because all the cylinders were buried and they were not the normal Lectures type cylinder, the assessments were pretty much the same as you do now. You're looking at the integrity of the body, how much damage has been done, how rust, has it been physically damaged, are there any gouges, cuts, or appearing separation. You're looking at the valving, checking the valving, the threading, does it appear to have leaked at any time, is the metals from the valving still intact? Are there any stress fractures in the cylinder? Has it been subjected to any thermal damage, like a fire or something? We actually had a couple of cylinders that were, it kind of gives you an idea how good cylinders can be, that they were almost bowed in half, like making them into a U shape because they had been bent. Something had been placed on them to bend them, and they didn't fracture, luckily. So it's the basic looking at the body itself, looking at the valving itself, looking at the integrity of the threads. Had it leaked? Has it been subjected to thermal? So basically all the different things. We did pH swipes on the outside. Has there any reaction taking place on the metal on the outside? So a lot of different things. But pretty much the same you do on any cylinder.
Okay, so nothing special for the hydrofluoric acid?
No. In this case, no. No, in this case, no.
In this case, no. Very interesting. What other hydrofluoric acid runs?
Oh, there's a couple more. There was We just had, I think we had another one that we had actually a tank leaking, an inside tank leaking, where that wound up being a very easy one. It was hydrofluoric. We had to go into a room that had been abandoned with hydrofluoric in I think it was a couple of 100 gallons. The thing is, these are never big incidents like rail cars or anything like that. And I know a lot of departments have dealt with much larger incidents when it came to hydrofluoric. But these are kind of unique because of the location and the other hazards associated with it. We had one that was actually kind of a funny one, but it was easy to resolve. But they had a leak in piping, and as you came down, it required you to go into this room that you had to walk down a concrete staircase. It was the only way to get into the room, and it just so happened that the product leaking from the piping was spraying directly across the pathway for the staircase to make entry into the room to try to deal with the leak. So we actually had to come up with a shield system, so as you walk down the concrete staircase, to put it up in front so that the leak would hit the shielding to allow the guys to pass, then get downstairs and work on closing up the leak in the pipe. And that became just a simple patch job. That was nothing major about it. And then it got turned over to be pumped out.
So, I mean, what was so we've got the hydrofluoric acid is what was leaking.
Yes.
What were the considerations? So you're going to come up with this game plan, right? And you have this product that literally just kind of reacts with everything. So how do you come up with a shield that is going to do what you need it to do? What was the thought process there? How did that?
We actually took almost, we kind of made almost like a ballistic, like the police use the ballistic shields that they carry for raids and stuff.
Okay.
And we basically made it out of plastic. And even though we know it was going to react somewhat, it still bought us time to get past. So the hydrofluoric, the leak, and it wasn't a huge leak. It wasn't like a fire, a hose leak. It was more like a pin stream leak going across. So it allowed us to put that up place and allow everyone to pass and get in there and deal with the leak right away, and then be able to not worry about the shielding anymore once that was done.
And when it came to actually patching the tank, you patched it just long enough, obviously, for the leak to stop, and then they had to evacuate the tank. Was there any consideration to what and how you patched because of the product? Like, if I have a gas, tank that's leaking, I'm just going to take some putty, possibly try to throw it on, or how was it patched? What did you guys do? Because that had to be some consideration too, right?
Oh yeah, it was actually a pipe leaking, not the tank itself.
Okay.
So the good news was that we were able to close a valve off to stop the actual leak in the pipe, and then we just had to deal with the residual that was left in the original before it had the leak in the pipe itself.
Gotcha.
So it wasn't, we didn't have to worry about putting a patch system on the pipe itself. We basically wound up capturing what was coming off of the pipe, the runoff from the pipe, which wasn't that much. And then dealing with the reaction in the air from the hydrofluoric coming out, knowing it was vaporizing and coming up. So we wound up trashing a bunch of level A suits on that one too, unfortunately. I mean, the level A business loved us because we were trashing suits left and right.
I'm sure. Now, you sound like this is not quite the first responder realm, right? This is more of a really enhanced contractor cleanup.
Actually, I'd say a little bit more than a contractor cleanup. The reason being is that the team that was put together for doing a lot of these projects, they were a very unique team. They had guys. We had ex-EOD guys. We had firefighters. We had paramedics. We had ex-law enforcement. We had health physicists. So it was a very unique team of individuals that had various backgrounds based on the expertise that was needed. And in a lot of these, this was not a normal contractor role to go in and clean up, because most of these teams, all these members had to have clearances to go in and do certain things depending upon what part of the world we were in. We were hired to do certain things based on our abilities, and then this team got together and actually spent a lot of time prepping and planning and looking at these projects. The other big thing is a lot of these projects, I will say, these were not, except for like the leak in the tank right there, they were time consuming from the standpoint of prepping to get ready. they were not, you're right, they're not the normal emergency responder would show up, like, from my hazmat team or working your hazmat team showing up saying, oh, this is what we're going to do to deal with these problems. This was, in some cases, months and months and months of planning and figuring out, and then actually running mock scenarios of what's going to transpire, what can go wrong, and then, okay, what's the plan A, what's the plan B, what's the plan C type of situation. So a lot of effort was put into it, and looking at all the hazards and what's, the potential for things happening. But we also wound up designing a lot of neat things to deal with these problems.
So, for instance, the hydrofluoric leaking from the pipe, how would you turn around? So you stop the leak, you stop the pipe from leaking, you deal with the product that's leaking, and then you have the contaminated area. Was that your responsibility to render that area safe, or were you just we stop the actual hazard, now somebody else come in and render the area clean?
In that case, we stopped the leak, we offloaded the tank, a small tank, again, it was only a couple hundred gallons, and then in turn, we vented the room out, and they brought in someone else just to do the final cleaning. And I forget what they used on the floor. It was a concrete floor to actually neutralize the floor. But that was only their task, was to neutralize the material that had gotten into the concrete. And most of the concrete had wound up spalling because of the hydrofluoric. So it was more of a clean up, take up, chisel out, take away, and get rid of it.
Gotcha.
And the good news was the room was condemned anyway, so it wasn't like it was it was going to be reused. And not that they would leave it the way it was, but it was not like it was going to go back into production the next day or something like that.
Well,
sorry.
It's quite all right. The fact that you have spent so much time planning these instances and doing the research on these instances, if we had somebody call you up while they were responding to some kind of a leaking tank, a hydrofluoric acid, and they were like, hey, listen, based on your experiences, just give me like 2 or 3 things that I should keep in the back of my mind while I'm approaching the scene and working around this stuff, what would those suggestions be?
Well, interesting. I mean, suggestions would be, first of all, know your risk. Obviously, that's the thing. Make sure it is the product you think it is. What other things are in the area? So I'll give you another quick example. A real side note: we were working in a facility that had a 55-gallon drum let loose in a warehouse, and when we pulled up, you could see the windows starting to craze in the warehouse from the hydrofluoric leaking. Knowing what else is in that area, so whether it's a tank car or a 55-gallon drum or whatever, or a fixed tank, is what else is in the area. What else if it's leaking, how bad is the leak, and if it's fuming, the vapors are attacking other products or other containers. What are those? What's in those containers that could react? Is there a potential for a catastrophic failure from the vessel or the tank or the container that you're working on, and could it cause a catastrophe for another tank? Looking at the protection, doing your recon and understanding what's there you're going up against, and what can I do to take my time to make sure I mitigate that. Am I going to patch it, or if I can't patch it, how am I going to contain the product, or can I absorb it temporarily and then deal with the neutralization after the fact? So I'm kind of just throwing stuff out, but there's a lot of different things you're looking at. Obviously, the bigger the vessel, the more product you have, the more concern you have where it's going, what's it doing. So those are, what's my recon team going to, how far am I going to let them recon? Things like that.
Yeah, so just, 1 or 2 things to keep in the back of your mind. Wow. It is safe to say there's definitely a lot that goes into dealing with a hydrofluoric acid run. And, boy, that's I would have never thought to really, expand your scene survey, do the full 360, see what else you could potentially be dealing with that could turn around and bite you in the ass while you're trying to mitigate one thing, something else is happening that you didn't even realize because you didn't take the time to really do a full scene size up with a chemical that can react with so many different things at any point in time.
The The other thing we never touched about is the medical part of it. Is, in all the cases, even as from the remediation part, is having your medical component in the background. And especially when you're planning, it's a lot easier. Like, we notified the local hospitals. We made sure they had the paste and the shots for it. Our medical staff on site, as a public response team showing up, showing up to an incident, you need to start thinking about that too. What happens? I know people don't want to think about the worst, but what happens if we go the worst? Do I have a hospital locally that I can bring someone that's been exposed to hydrofluoric acid from contact with skin and stuff? Do they have do they have the paste? Do they have the shots they can give? So are they capable of dealing with this? And if not, I better start reaching out real quick, still knowing I have to do something quickly, especially in the public mind. But I need to make sure I have those components in place.
Oh. So really, I mean, it's even a first responder, even somebody who's got an emergency situation happening, they really need to take the time to make sure things are set up, not just, we think, all we have to do is have an emergency decon set into place technically to go into an area, but really that emergency decon needs to extend to medical, to hospital, and to make sure the logistics are set up to get somebody from point A to point B, if need be, very quickly.
Yeah. And once I get them there, can they actually do something to help the person? I mean, yeah, they can treat burns, but what else can they do for it? Or do they have to move that person to another hospital that can do it? Obviously you have to know your immediate response area, and like any good hazmat team, they've looked at what's out there, what can our hospitals do for us, based after the decon. In some cases, can they do decon at the hospital itself? And what antidotes do you have, or what other things that do you have that can help us if we're coming in hot, so to speak, with an EMS crew bringing somebody in that's been decon but may have contact, with any product for that matter. It doesn't matter with hydrofluoric or anything, but what can they do to help us?
What would your medical teams be backed up in? Would they, if they, let's say you got exposed, you had a pretty heavy duty exposure, you did your decon, the medical team came in, are they going to be in any level of PPE, or are they pretty well protected, like they don't really have too much of an exposure hazard?
Now, speaking of what I was just doing, the little case histories we were talking about, they would not touch the person until we got everything cleared out and the person taken out. Do an emergency. We actually designed back then. We designed our own emergency cut-down kits for level A. We had the procedure set up for emergency response to get the people out of the suits. It was just that we would hand them over to them after we got them out of the package, so to speak, and we made sure they were clean enough to be handed across to EMS, and then they would deal with it.
So would you? Is it just the general decon? So here's my thought process. Like, we have chemical suicide, a person involved with a chemical suicide, and we want to make sure that we are monitoring the air for that victim, because the person can be off-gassing the chemical. So our technicians, our EMTs, need to take special precaution. If somebody gets this burn on them and they wipe it off, soap and water, is there still a potential contamination hazard for the person helping them?
If they get it on direct contact, obviously you're trying to clean it off as best you can. But once you're still going to have the hydrofluoric doing damage to the skin. But once you get most of it off, it's done. Now it's more of a medical issue from the person himself. Having the direct contact. How deep is the wound? How long were they exposed to it on the skin? Did they inhale it and things like that? If they're still breathing, it's still in their system. And then, yeah, you're right. From a chemical suicide, you're worried about what's still left in the person's lungs, where we've actually pumped people's lungs and made sure there's nothing left in their lungs, or put them in a body bag and taken readings off the body bag after sitting them outside for a few minutes, so the coroner wouldn't get whacked with it. But if they're still alive, you're trying to, obviously you're trying to get them to the medical treatment they need. Like any chemical burning, acid burn, you're trying to get as much off of them as possible. How far did it go? How deep did it go? Try to wash it down as best you can. Notifying your EMS crews as you turn them over, this is the contact area, and then the hospital going from a direct exposure to EMS with the hydrofluoric, unless, there really shouldn't be that much of an issue once you've taken the gross decon process and remove, like any decon, remove the stuff from the person, their body, that is. whether it's through clothing taking off or their PPE taking off, whatever the case may be.
Very cool. Stephen, a lot of great information, insight, and experience to share with the community. I absolutely love it. If somebody had a question and they wanted to reach out, how would they get a hold of you? Do you have an email address? Would you prefer them to go through us?
No, they could email me. They could I can send them an email to my personal email address. I can give that to you.
And we'll put it in the show notes.
Yeah. I hope I didn't bore you with any of this.
No, not at all. Great lessons learned.
Great. Well, thank you again for inviting me, and I hope I gave somebody. I mean, I think these are different than public responses. I understand that, and they're a little unique. But you never know when you can run across something from your public hazmat team going in and having to deal with situations like this. So just being prepared is the biggest thing, and having an understanding of what's in your area. So
that's the understanding what's in your area is absolutely huge, and we encourage everybody to kind of go through their tier 2 reports, their local tier 2 reports, and see what's in your area. You would be very surprised what chemicals are being held in facilities all around you.
Oh yeah, I mean, I still run with Bucks County Hazmat Team also, besides being a career chief here, and we're always looking at what's in our county in Pennsylvania. So, and what do we need to do to be prepared? So it's a never-ending job.
It really isn't. It really isn't. All right. Well, thank you very much, and we will talk to everybody on the next show.
All right. Well, thank you again, and have fun with your daughter today, okay?
Thanks, I will.
All right. Bye-bye.
If you have a moment, please head over to iTunes and leave us a positive review. And don't forget to check out the book, National Emergency Response Hazmat Drills, or NERD, on Amazon.
Well, that wraps up another episode of the Hazmat Guys.
You can find us on Facebook, Twitter, and our YouTube channel at the Hazmat Guys. And take a moment to call our comment hotline at 843-628-1484 and go to www.thehazmatguys.com and sign up for the newsletter.
We seriously look forward to your feedback about any of the information provided, and we also want to hear about interesting incidents that you were a part of. So you can send us a note at feedback@thehazmatguys.com. And remember, any of the information that you share with us, if we put it on air, can always remain anonymous.
Remember, guys, don't just get on the job. Get into the job.